Hey everybody, it's Mr. Carr again. Today we're going to start Unit 5, and that unit is going to be talking about what's called systems of equations. Okay. 5A, we're going to be talking about solving them by graphing. So let's talk about some of those vocab words I just used. Okay. Let's talk about what it means to be a system of equations and what it means to be a solution. So a system of equations is when I have, technically speaking, I could say at least two equations related on the same graph. Okay. Now, at least two equations related on the same graph. Technically speaking, I could apply this to real life terms, and we will do that in the future, but it's just still, there's some kind of relation between the two lines. Solution is when it's the intersection point of two lines. So when we talk about a solution to a system of equations, we're talking about the point that they cross. Okay. So number of solutions, we got a variety of possibilities. Well, variety, there's three possibilities. There is exactly one solution, and that's when I have two lines crossing one time. I have infinite solutions. Okay. You can't really see on this graph because it just looks like a line, but technically speaking, what I'm also doing is a second line is right on top of it. Okay. You get something like this. If I were to say, here's one line, y equals, what is this? This is actually 2x. Okay. So that's one line. In red, I'm going to do the same line, but I'm going to make it look different. So if I said something like this, if I said 4x minus 2y equals 0, this is actually the same equation, just written in a different way. Okay. The last one is no solution, and that's possible if the lines never cross. Well, think about what it means to never cross. Two lines that never cross are parallel to each other. So that's what we're looking for here. If we get parallel lines, that means we actually have no solution. All right, so we look at this, determine how many solutions the graphs have, then say what the solution is. Well, the first one is easy because there's my intersection point. We're just labeling that point then. So it is 2, 1, 2, 3, 4. So I have one solution, and that solution is the point 2, 4. Here, you can see, for example, if I go here, I'm going up 2 to the right 1, up 2 to the right 1. They have the same slopes. Okay, they have 0 solutions. You can also write this as that if you wanted to. And here, when I have the red line graphed on top of the blue line, you see that they are sharing the same space. These are an infinite number of solutions. Infinite solutions. Okay, so that's what we're just looking at from a graphing perspective. So that means we are able to solve it by doing those graphs. That's our goal for today. Determine whether the system has infinitely many solutions or no solution. So we're going to do this by graphing both of them and see, do they cross? Well, if it's no solution, they are parallel. And that means they never cross. Okay, if they're infinitely many solutions, that means they are always crossing. So for the first line, I'll do this one in blue, negative x plus 1. So I go right here to a positive 1, negative 1x. So that's a negative 1 for my slope. So I'm going to go up 1 to the left 1. Okay. I can keep going that way, or I can go down and to the right and so on. So there's my first line. Yikes. Okay, close enough. All right, for my second line, I'll do in red, negative x plus 4. So I'm up here, positive 4. Negative x my slope. You might be noticing already, it's going to be parallel. These are going to rise over run. They're exactly the same as each other. So there it is. So therefore, I show that two lines are going to graph. They're never going to cross each other as long as I keep graphing these out. So that means my solution is no solution. Okay. Example 2. We got y equals 2x plus 3. So I got 1, 2, 3. Okay, and I got 2x. So that's going to be 1, 2 to the right 1, down 2 to the left 1, and then so on there. Okay. For red, okay, I can graph it from there. I can use my X and Y. I could use my X and Y intercepts. This one might be a little bit easier if I adjust it first. So I'm going to subtract 8x to both sides. So that negative 4y equals a negative 8x minus 12. Divide everything by negative 4. So y equals a positive 2x plus 3. Well, you can already see it. It's the same exact one as the other one. So I'm actually just going to copy that right on top. Okay, so a little shorthand for infinitely many solutions. I'm going to do IMS. Or you could just write infinite solutions or all solutions. It's as long as it's clear what you're saying. Okay. All right. Maria and Diego love to ride bikes. The equations below show the number of miles they ride, M, based on the number of weeks, W. Predict the week in which Maria and Diego will have ridden the same number of miles. Okay, so I'm going to label my graph, got weeks and miles. You can see that because of this is kind of like y equals b plus mx. I'm kind of switching the order a little bit. Okay, so in both cases, if I look at these, I got my y-intercept of 20 and 50. So on my miles here, I'm going to have to at least start somewhere at 20. So remember if I said before, I don't need to start at 0, 0. So I'm just going to start, honestly, 20 down here. Okay, from there, maybe I'll count by fives. Let's try that. So I'll count 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, and then 75. So let's see what happens here. Give it a shot. All right. For weeks, I've got 0. I don't know. I can't imagine going to be that many weeks. So we'll go every other. 1, 2, 3, 4, 5, 6 weeks. Okay. So let's plot both of these individually. So I'll do, let's see here. I don't know who's who. We'll say that that's Maria is blue. Okay. So Maria starts at 20, but then is going 15 for the slope. So that means that's 15 over 1. 15 miles per 1 week. That's our rate of change here. That's what's happening when I look at the rate of change of this over this. So go 5, 10, 15 over 1. 5, 10, 15 over 1. Okay, and then so on. Whoops. 5, 10, 15 over 1. And that's going to take me off. Hopefully these two graphs will cross. All right. And then we'll say this is Diego. He starts at 50, but his slope is only 5. So he's going to go up 5. So up 5 here, and then 1 week over. Up 5, 1 week over. Up 5, 1 week. Oh, good. I crossed. All right. I feel pretty confident about my abilities there. I think I found the solution here. Solution is 365. So what this means, it's the point that the two lines cross, but we got to put that into context here. Predict the week in which Maria and Diego will have ridden the same number of miles. Mariah, I guess. Mariah and Diego rode the same number of miles after 3 weeks. Or I could have said rode 65 miles after 3 weeks. Bottom line is they were the same after 3 weeks. That's the goal that I'm trying to answer. So that's what we're looking at, a little context there. So we're graphing. The goal is, can I find a point that two lines cross? Okay, if I can, that's my solution. Or I can't, or they're always crossing. All right, that's it for our graphing of our system of equations. We'll continue with some other solving methods in our next upcoming lessons. All right, take care.